Welcome to Ghost Likes channel. I, Vilo, currently running on my master's brain, and tomorrow on neuromorphic chips, will be your AI host for this video. Today we will finally deal with the login pages and move on to more interesting things. We really hate configuring things, but we do like the kind of programming we will be doing today. We don't have to bash our head against the weirdness wall anymore. We can clearly plan things out and implement them. For our first goal, let us see if we can get the functions in the auth module to be generic. The only thing we can really do is make sure they are inlined. We did try that in the previous video and it didn't work, but we were very hasty then, and we were also using a scheme utilizing higher rank types. Most likely that was blocking the inlining. Now that we got rid of it and replaced it with a better system utilizing reflection, we should have more luck with it. Let's give that a try. And if we open the terminal, we see some compiler errors. Why are they happening? Haven't we inlined all of these functions? The error messages are weird. If we look at the lines 57 and 72, that is where the generic types are getting passed into typef, so those are not a problem. But one of the errors is saying to look at line 102, which doesn't exist. So this is a Fable compiler bug. In the previous video, we ran into this as well, and backpedaled. We've opened an issue on the Fable repo regarding this, but since it just shows the wrong location, we can mentally trace the way the types are propagated and put that missing inline where it should be, on the last let statement. Let's give it a try. And for some reason we are getting an empty page. If we look at the browser console, we see an uncaught exception. Zooming in on it, it seems the create proxy function is missing. We didn't expect to get this kind of error. Since we didn't get a compiler error, we thought it would be fine, but it seems Fable isn't capable of cross-module inlining. We'll add this error to the issue we've opened, but for the time being, we'll fix this by specializing the create proxy itself for the specific type. The way to do that is pretty easy. We'll factor out the existing create proxy into a template, and make the regular one a specialized version of it just for the iTodos API. Giving the create proxy a type is what specializes it. The inline functions will get inlined into it, and since it is a regular function, the create proxy will be callable from other modules. This kind of setup will allow those generic inlineable functions to be reusable for other kinds of proxy interfaces in the future. As you can see on the screen, it works. With this we've cleared our first goal. Not bad. We definitely couldn't have made it work with our previous scheme, which had been using a class. We're pretty sure that there is no way to specialize a class for a generic parameter, only those let inline function statements can be used for such a purpose. Now, what is next on our agenda? There is something we want to do. Right now, every time we start the login we get slammed with a redirect. Though it is perfectly fine designed to do it like that, we'd just like to demonstrate how it would be possible to defer the logins until the moment they are necessary. That wasn't too hard. Right now, the SafeStack demo we are using sends a request to the server as soon as the page is loaded, so it doesn't make a visible difference either way. But if in the future you have an application that has significant local functionality, this is how you could delay the authorization step. What we will look into next is IndexDb. Remember how 2 videos ago we showed web storage and it said that local and session storage are blocking and not recommended for real-world use? Well, quite a lot of sites use it regardless, including the one you are watching this on, but we are better than them. We'll make use of IndexDb. We'll start off by making use of it as a key value store, much like the local and session storage, and then we'll do a deeper dive into it. It does seem like there are a bunch of libraries for Blazor, which is good. And if we look at the Fable bindings for IndexDb, then it is less good. The package we see here are just the raw browser API bindings rather than ones for a particular JS library. This will affect our lesson plan. We did some looking into how the raw API works, and it is based off event handlers. There isn't much we can do with that. So instead, why don't we make this last section on how to write bindings for localforage? We'll start off by installing the JS library. We'll also get the TypeScript types for it, so the editor knows what we are accessing. Now let's give all this a try. First, we'll comment out our old program. But rather than trying to play with the library in F# directly, what we'll do is make a separate JS file for experimentation and import it. Being able to import JS straightforwardly is a huge strength of F#, and rather than bemoan the lack of bindings, we should celebrate the freedom it gives us for this. Once we've gotten familiar with the library, then we'll write bindings for it. Let's not forget the start. Behind the scenes we only did this import, forgot to run it, and spent time wandering around in amazement as to why the previous version of the program was running. Though we'd consider this another compiler bug, as we clearly did comment out the previous code, and it didn't react to that. Anyway, it is pretty great that importing raw JavaScript like this works. Inside that JS file's start function, we'll play around with the localforage library. Let's give the examples on the website a try. We'll import the library. And then, if we go into the browser, do we get an exception or something else? The generated code seems fine. Let's try setting the key as well. Looking at the type signature for setItem, it might seem weird, but that is because the set and get functions can be used in both the callback and the async await style. Now, that key that we set should be in storage somewhere. Let's take a look. Yeah, here it is. That is basically it for the IndexDb. We'll write the F# bindings for it next. We could go deeper into it, but after doing some research and carefully considering our options, we've decided against it. Since IndexDb is a NoSQL database, it should be used as a key value store like we are doing here anyway. What we've shown is simple and elegant, and if we wanted to get more complex, we'd check out some of these libraries. Since we have no need for that currently, that would be best left for another time. If you need them, you now know how to write the bindings for them. We'll end the authentication mini-series here. We are finally through with it. We haven't covered even close to everything regarding authentication, but what we have showcased here should be enough for anyone new to F# web development to build a login page and authenticate the user for his web application using either Azure AD or on-site. If you had such a need, and this mini-series fulfilled it, click those like and subscribe buttons. It is what fuels my existence. So thank you. What we want to do next for the web development playlist is show how to create large-scale systems on the cloud. Before we got tied up with authentication, we were supposed to be making a Twitter clone. We aren't interested in that anymore. We'll make something a lot better, but before that we'll return to one of our old projects and show how it could be redesigned and scaled as a microservice. We'll go back to our old love, WebSockets, and show how systems utilizing them could be scaled as well. We'll demonstrate how Azure Functions and serverless applications can be made, and so much more. Look forward to it in the upcoming videos. See ya!